Dear students, in this video we are going to discuss about the computation of DFT using DIT method. There are two FFT methods. One is DIT, decimation in time, and another one is DIF method. In this video we will discuss about DIT method with one example. To find endpoint DFT using DIT method or DIF method, we need n by 2 total factors. That is, if n is equal to 8, we need 8 by 2 equal to 4 total factors. If n is equal to 4, you need 4 by 2 equal to 2 total factors. For n is equal to 8, we need 4 total factors, and the 4 total factors are w8 power 0 equal to 1, w8 power 1 equal to 0.707 minus 0.707j, w8 power 2 equal to minus j, w8 power 3 is equal to minus 0.707 minus 0.707j. For n is equal to 4, we need 2 total factors. One is w4 power 0 equal to 1, and another one is w4 power 1 equal to minus j. These are the total factors for n is equal to 8 and n is equal to 4, and it is common for both DIT and DIF methods. This is the basic butterfly diagram for DIT-FFT method. Here the inputs are A and B, and the total factor is represented by n power k. Here we have minus 1. This is the basic butterfly diagram for DIT method. Now I can find the output here. Here you are having A, here you are having B, but on the way you have Wn power k, so B multiplied by Wn power k coming to this node, and they are getting added. Already you have A, now you have B Wn power k, both are added, so the output is A plus B Wn power k. Here you are having A to this node. Here you are having B Wn power k. On the way you have a minus 1, so A, this minus B Wn power k. This is the basic butterfly diagram for DIT method. For DIT-FFT method, you should remember two things. One is the input is bit reversed order, and the output is natural order. But in the case of DIF, input is natural order and the output is bit reversed order. Input is natural order, output is bit reversed order. But in the case of DIT method, the input is bit reversed order, but the output is natural order. If you understand this basic butterfly diagram, then you can find 4-point DFT problems, 8-point DFT problems very easily. Let us consider a 8-point DFT problem as an example. This problem is using DIT-FFT algorithm. This figure shows the basic butterfly diagram or the signal flow graph of 8-point DIT-FFT method. This is the expanding butterfly because in the first stage it is like a 2-point, it is like a 4-point, but in the third stage it is like a 8-point method. So it is like a expanding butterfly. In this butterfly diagram, in the first stage, for a 2-point, we use only one total factor that is W8 power 0. For a 2 point, we use only one twiddle factor, that is W8 power 0. In the second stage, it is like a 4 point, so we use two twiddle factors. One is W8 power 0 and another one is W8 power 2. Here also W8 power 0, W8 power 2. In the third stage, this is 8 points, so we use 4 twiddle factors, that is all the twiddle factors W8 power 0, W8 power 1, W8 power 2 and W8 power 3. As we already know, the input is written in a bit reversed order. We can write the bit reversed order very easily with the help of a shortcut. For that, you have to split the given input into two sections. Section 1, section 2. Then you have to write the first terms of the section 1 and the first term of section 2. Next, you should write the third terms 3. There the third term is 7. Then we should write the second term. Here the second term is 2. There the second term is 6. And finally the last terms, here it is 4 and here it is 8. First term, third term, second term, last term, that is fourth term. 1, 3, 2, 4 concept. Next we will do the stage 1 calculation. Here you have 1, here you have 5, multiply with the twiddle factor 1 and then added. So 1 plus 5 into twiddle factor is 1. Next, here 1 will come, here 5 into 1 multiply with minus 1. So on the way you have a minus, so 1 minus 5 into 1. 1 minus 5 into 1. Next, here you have 3 plus this is 7, so 7 into 1. Next, here you have 3. On the way you have minus 7 into twiddle factor, so 7 into 1. Next, here 2 plus 6 into twiddle factor is 1. Here it is 2. On the way you have a minus, so minus 6 into twiddle factor. Here you have 4. Here you have 8 multiply with the twiddle factor. We already know the twiddle factor is 1. So 8 into 1. Next, this term, here you have 4 comes here. On the way you have a minus 8 into twiddle factor. Now we can calculate 1 plus 5 into 1 is 6. This is minus 4. This is 10. This is minus 4. This is 8. This is minus 4. This is 12. This is minus 4. We can write these terms here. 6 minus 4. 10 minus 4. 8 minus 4. 12 minus 4. Next we can do the stage 2 calculation. Here you have 6. Here you have 10. Multiply with the twiddle factor W8 power 0 equal to 1. So 10 into 1. Here you have minus 4 plus here you have again minus 4. Multiply with the twiddle factor W8 power 2. We already know the W8 power 2 is minus j. So you will have minus j here. Next, this term, here we are getting 6. On the way you have minus. Here you have 10. Multiply with the twiddle factor 1. Next, here minus 4 will come. Minus, why minus? On the way we have a minus 1. Minus 4 into twiddle factor is minus j. Here you have 8 plus here you have 12 into 1. here you have minus 4 plus here you have minus 4 with the total factor. Minus 4 with total factor is minus j. Here 8 is coming. Here on the way you have a minus, so minus 12 into 1. Minus 4 is coming. On the way you have a minus. This minus 4 is multiplied with total factor. Minus 4 is multiplied with the total factors. Now the calculation 16 minus 4 minus plus 4j. This is minus 4. This is minus 4 minus 4j. This is 20. This is minus 4 plus 4j minus 4 minus 4 minus 4j. Now we can write the terms in the signal flow graph. This is 16. This is minus 4 plus 4j. Again minus 4. Again minus 4 minus 4j. This is 20. Again minus 4 plus 4j. This is minus 4. This is minus 4 minus 4j. Now we can do the calculations for stage 3. Here 16 is coming. Here 20 is coming with the total factor W8 power 0. W8 power 0 we already know it is 1. So 16 plus 20 into 1. Next you have minus 4 plus 4j plus here also you have minus 4 plus 4j multiply with this total factor W8 power 1. This total factor we already know the value is 0.707 minus 0.707j. So you will get minus 4 plus 4j into 0.707 minus 0.707j. Next this term, here you have minus 4, here you have minus 4 combined with this total factor. Minus 4 combined with this total factor. Next this term, here you have minus 4 minus 4j plus here also you have minus 4 plus 4j combined with this total factor. So minus 4 minus 4j combined with minus 0.707 minus 0.707j. Now you can use calculator to find these answers. Here you will get 36. If you use calculator to type these complex values, you will get minus 4 plus 9.656j. At the end of this video, I will explain how these terms can be entered into a calculator to get this final result. Next term minus 4 plus 4j. Next term if you type exactly same like this, you will get minus 4 plus 1.656j. Here we found only 4 values, 1, 2, 3, 4. The other values can be obtained by replacing this plus into the minus sign. Here also if you replace plus into minus, you will get the result. Here also if you change this plus into minus, you will get the result. Here also you need to change this plus into minus to get the other 4 results. These are the final values obtained with the help of calculator. And the answer can be written in natural order. Here the input is bit reversed order, but the output is in natural order. Here the discrete Fourier transform of x of n can be represented by the symbol capital X of k. DFT of small x of n can be represented by the symbol capital X of k. This is the natural order of the output while calculating DIT method. Now you can easily check whether our answer is correct or not. For that, you can cross verify with the help of the given problem. Let us write the given problem. X of n is equal to 1, 2, 3, 4, 5, 6, 7, 8. If you add the given sequence, that is the sum of x of n, you will get 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 plus 8, you will get 36. That will be in the first term of the answer. First term means zeroth element. This is the zeroth element of the answer. If you add the given sequence, then you will get the first term of the result. Next, you add the x of k terms, that is sum of x of k. This 9.656j and minus 9.656j getting cancelled. Minus 4j plus j will be cancelled. Minus 1.656j plus 1.656j will be cancelled. Now you have 36 minus 4, minus 4, minus 4, minus 4, again minus 4, again minus 4, again you have minus 4. 36 minus 4 is 32, 28, 24, 24 minus 4 is 20, 20 minus 4 is 16, 16 minus 4 is 12, 12 minus 4 is, overall you will get 8. Now you divide it by capital N. Capital N is 8-point DFT. From the question we know it is a 8-point DFT. So if you divide with N, you will get 8 by 8 is equal to 1. You will get the first term of the question, that is small x of 0. This is the method to check whether our answer is correct or not. I am explaining again. If you add the given sequence, you will get the first term of the answer. If you add the final answer, that is DFT answer, and divide it by the n value, you will get the first term of the question. First term, that is zeroth element of the question. This is the easy method to verify the final answer of DFT. If you use DIT method or DIF method, you can verify using this technique. In this problem, our answer satisfying both the equations or both the conditions, so our answer is correct. In this section, let me explain how the complex values are being typed in calculator to get the final result. I am going to explain with the help of FX991 MS calculator. Steps are, first you need to, on the calculator, press the mode button one time. You have complex mode, you have a complex CMPLX mode in the number 2. Next, you have to type the complex values. Let us consider this example. Take a calculator. After on, mode and setting complex, you need to type minus 4j. You cannot type j, instead you can type I. For that, you should use ENG button, which is in the middle of the FX991 MS calculator. ENG button, you will get I. Next, you will type plus bracket open minus 4I, multiplying bracket close and multiplying symbol. Again 0.707 minus 0.707, you cannot type j. You can use the same ENG button to enter I. Instead of j, we are using I. You will get minus 9.656j not j, simply 9.656 in this calculator as a real part. The calculator will show only the real part. If you press the shift and then put the equal button, shift plus equal button, shift plus equal button shows the imaginary part. Here the imaginary part is minus 4i. You can use j here. So the answer is minus 9.656 minus 4j will be the answer for this complex term. Thank you.